Alrighty, I think I've got things set up on my end, ready to rock. If folks can let me know if I'm 5 by 5, let me know if you can both see and hear me okay. You should be looking at a nice picture of some of my students on a recent field trip down in northern Utah, and then a little inset box with my lovely mug at the bottom right. So just let me know if you can see that okay. Test, test. Am I coming through? Anyone? Just looking at the live chat to see if folks are seeing and hearing me okay. We'll get started at the top of the hour. Let's see here. Brian E says I'm 5 by 5. Awesome. Always a good thing when we can see that the technology is smiling favorably upon us. So excellent. Thanks so much, team. We'll do shout outs as always, just for fun while we wait for everyone to file in here and for the top of the hour. I looked over a couple folks there. Sandrine is here from France, Brian E., a lot of the regulars. Elizabeth from cloudy Scotland. Yeah, make sure you hit the like button. That's always helpful. Helps us spread the channel to new folks who might be interested in the types of stuff we do here, grow the community. That's always good. And Virgil from rainy Billings, Montana. Hope you get some sunshine. We're supposed to have a fantastic weekend here in southern Idaho after a stormy start to the week and then a couple of really windy, cold days. I was out yesterday doing field work. I'll show you some pictures from that. It was chilly. I had my puffy on, but next couple of days look great. So looks like folks are coming through here. That's awesome. We have our moderators here, Susan and Mandy Joe. Lisa may be joining us as well. So if you guys can follow their prompts on how they want to run the live chat, that would be wonderful. Chris is chiming in from the Netherlands. How are you? Sue Ellen from Rochester, New York. Flavio from Australia. Good day. Fredio from Virginia. Mark from Phoenix. Shauna from Sydney. Christensen from Iceland. Yeah, that's a tricky first name for me. My Icelandic is still so rusty and just not awesome. Hans Heinrich from Copenhagen, Jim from Dartford, UK, Katmanku from Lodgepole, Alberta, Laws from sunny Lancashire with their daughter Jo. Greetings. Thanks for joining me today. Paul from Glasgow, Scotland, Mark from Puerto Vallarta, Mexico, Steve from Forest Ranch, California, Susan from the UK, Cactus Wren from Socorro, New Mexico, Petro Guru, oh, that's Mike from Boulder, Colorado, Jim from Dartmouth, oh, I did that one. Keep track of where I'm at on the live chat here. Lean from Northern California, Aloha from Hawaii, says Joyce, aloha. Jill from Tampa, Florida, Jan from Southern Alberta, and then it jumps down and I lose track like it always does. So if I skip you, I apologize. Lorraine from Kingston, Ontario, Hard Rock Girl from sunny Dorset. Aston, yeah, I got a pretty crazy schedule. I'd love to meet some Icelandic viewers if it works out. I don't know exactly how to do that. I'm going there for the first week with students, so I'll be kind of like, mainly focusing on them and getting them to different spots, being the ringleader for that. I do have a few days in between their trip and then another trip of YouTube viewers that I'm taking around Iceland as well. Aston, it would be great to meet you though at some point, and I know you live close there to the Reykjanes, so I think it could work out. Maybe just shoot me an email and we can see how things might work. So, and just so Amanda Joe knows, I do have a little bit of Kilauea update that I'll get to before we get to the Iceland stuff. So I saw your note about focusing on Iceland events, but I do have a little bit of information I want to share on Kilauea, which I've been doing a few updates on recently as well. Okay, Paul is in Austria, Barbara's in northern Idaho, Bo is in Sweden, Bad Shark in Cheshire, UK, Anna from Portugal, Brian in Vancouver, Washington, saying it's going to be 90 tomorrow. Yeah, the yin and the yang of spring weather in the western U.S. Kim from rainy northwest Ohio. That might have been our storm that has now reached you. Giles from the Netherlands. Awesome. Alb Russell from Scotland. Stevie Pinhead from sunny Seattle. Joanne from the Netherlands. Greetings. OK Madsen from Denmark. Gloucestershire, Massachusetts. Is that how you say that? I know there's different accents near Boston. From Laura. Bruce from London. Peter from Agora Hills, California. Richard is here. Greetings. Safi19 from Stirlingshire, Scotland. And lots of other folks there. You guys can read this as well as I can, but it's nice to get the verbal shout. We'll do another minute or two, and then I'll get this thing started at the top of the hour. If you're watching this on replay, you can obviously skip ahead to the official start here. I'll add the chapters to the video after it's uploaded and posted, so you can skip ahead to whatever section you would like to view. Lauren Elizabeth from the Ridge and Valley of Pennsylvania. Wendy and Magnus from South Iceland, greetings. Kate Batt from sunny Cambridgeshire, UK. Optimus Clang from Edinburgh. Patty from Pennsylvania. Billy from Portland. Ola says, oh, I missed that one. It was a good Spanish one too. Ah, nuts. Now it's gone. Oh well, it jumps down. I think it's almost like the live chat loads a bunch of comments, and then it just, on my screen at least, it just, on OBS Studio, it just takes off. Oh, there it is. Federr, Ola from Caracas, Venezuela. Richard from Wenatchee. Karen from the Catskill Mountains. Susan says it's going to be nice in north central Idaho. All sorts of good folks here. Johan in Sweden. Oh boy, under a tornado watch in Athens, Georgia. All right, be smart there. Stay indoors. Hopefully that goes well. Yeah, they've had some nasty tornadoes in different parts of the Plain States, and now I guess in the southeast. Olaf from Germany. Eastman from South Korea. That's pretty awesome. Paul from Missouri. Eartwin from Holland. Another Shawn from Salem. Zoe from Austria. Diane from Portland. Weather looks good in Iceland. I hope so. I'll be there on Tuesday morning. Yvonne from the Scottish Highlands. All sorts of great folks in here. So excellent. Thank you so much for joining me. Well, it is officially 10 o'clock on my little clock here on my computer. So thank you for joining me. I'm Geology Professor Shawn Willsey. We're doing a special live stream broadcast today. We'll be covering several topics. I'll start out with just a few photos of some of the things I've been doing out in the field lately. Spring is a special time to get students outside. Once we're kind of past the crux of the weather, allows us to get students outside and see some things, but I've also done a few of my own things outside. And so I'll show you just a few pictures. We'll get into a few maybe announcements, programming notes. I'll do a brief, maybe 5-10 minute or so update on what's been happening in Hawaii on Kilauea. And then the bulk of our time will be spent on Iceland. And then at the end, we will loop back and allow viewers to submit questions. Excuse me. Clear my throat. And please follow the prompts on our live chat if you want to submit a question to me with our great moderators. We appreciate their time in helping out to kind of keep things organized, aggregating the questions, helping me keep my sanity. It wasn't that long ago that I ran these on my own, and it was more than a three-ring circus and much more than I could handle. So thanks again for joining me. I appreciate your time. Let's see. So let's just start with some fun pictures here. And I'll go through these pretty quickly. We don't need to spend too much time on this. This is a small class. I had 5 students in this class. My historical geology class. This is out on Antelope Island, which sits in the Great Salt Lake. So we're looking east there at the Wasatch Mountains, a big continuous mountain range that's been pushed up by normal faulting over the last 15 or so million years. The Great Salt Lake is quite low due to sort of the drought conditions we've had over the past few decades, and so you see the sort of salty, marshy flats kind of extending further out there to the east. But here the students are looking at some wonderful Proterozoic basement rocks, these wonderful gneisses. There's also some schists and amphibolites as well. And then this is further up the ridge there. There's the whole crew with a great view of the Wasatch Range in the background. So I just thought it'd be fun just to share a few of these photos, just get you guys excited. I always like, it just helps to look at rocks, right? That's always helpful to me. So there's my wonderful students. It was kind of a breezy day. We ended up getting rained out the second day, but we got a good first day in. These are some of my favorite rocks up near the top of the ridge. These are diamictites, which are basically very poorly sorted sedimentary rocks that contain very large and very small particles all jumbled together. Fundamentally, you could think of it as a breccia or conglomerate, but the particle size range is even more extreme. And these are evidence of snowball Earth. So some of you might have heard of this really kind of cool event in Earth's history around 700 to 650-ish million years ago, when we have good evidence, because we see these rocks on all continents, that the entire planet, or nearly the entire planet, was encased in ice. And so these are some of the glacial sediments, the till, if you will, that was deposited during that global glaciation event. So snowball Earth, and then just above it here, these lighter colored rocks just beyond this outcrop here, these are some of the cap carbonates. These are the dolostones. Again, we see this succession of rocks on all continents. Probably a good subject for another video somewhere. But I did do a video of this exact same area maybe about a year or so ago for Antelope Island, and I did 4 videos, and then I put them all together into one later. But I did this exact same transect through these different rocks here if you're interested. So very cool spot. Let's see, what else have I done? Oh, this was actually just yesterday. So this is a fun little spot in southwestern Idaho. The butte in the distance is about a 7 million year old freshwater reef made out of mostly algae. And so I did a video on not specifically that outcrop, but that layer in a different location. And then in the foreground here, what you're seeing is this brick red unit with some basalt sitting on top. So this is some lake sediments from Lake Idaho that were actually baked by this overlying lava flow. So as that lava poured over the top of it, it actually baked the sediments, made them harder, turned them into this brick red color through oxidation. Anyway, cool little story, nice little area. It was very windy, but I love this time of year in Idaho. Everything's as green as it's going to get, even though we're in a desert, and it's not as sticky and prickly as it is later in the summer. What else do I have here? Just a couple more. I have a couple more road cut videos coming your way, so I thought I'd just throw those in there. I don't want to tell you about those now to spoil them, but here's one little teaser random road cut that's coming your way. This is on State Highway 51. So there's one there, and there's another one I did. This is State Highway 78 in southwestern Idaho. So a couple random road cut videos will be coming your way over the next couple weeks for those that enjoy that series. Again, field trips with students. This is my 101 class out at City of Rocks. They're sitting on a big chunk of this 28 million year old granite, the youngest granite in Idaho. And they're writing down their observations. They look so studious. They're looking at rocks. Good stuff happening there. Another view just in a different direction. Kind of give you some perspective of how big the cliffs are there, and they get much bigger than this actually. Some of the spheroidal weathering of the granite, pretty interesting. And I've done some older videos on City Rocks. I think I want to go out and redo a couple of them because it's such a cool place, and there's some really great exposures there. And I think I got one more after this one, but this is the same group. These are some tilted quartzites. So these were the rocks that the granites intruded into. And so the granite and some regional tectonic activity has caused these rocks to deform and be tilted. So these used to be sandstones, but they are now tilted and they're dipping steeply to the east in this case. So students just checking these out, trying to figure out what kind of rocks they are, what the history is. All good things happening there. There's active learning in the works right there. And then this is the last one. This was a couple days ago. I went out to Little City of Rocks, which is about 45 minutes, an hour from Twin Falls. And I did a video there that will be coming out soon as well. So if you're interested in knowing more about these rocks, how they formed, what their story is, you can look for that. So just some fun little pictures there. Let's go to Hawaii first. But before we go with Hawaii, let me give you just a couple of programming notes. So as many of you know, I'll be in Iceland from Monday the 3rd. Well, I'll get there Tuesday. From Tuesday the 14th to May 30th, I'll be there with a group of students for about 6 days, showing them around the area. I'll have about 3 days on my own to do a couple other things, record some videos, and then I have a small group of YouTube viewers that I'm taking around for about a week. All that being said, as we'll see when we get to the Iceland update, there's a lot in flux with respect to this new eruption. I'll try to cover things as best I can, but my days will be busy taking people to different sites. I will bring my laptop and be able to do updates as best I can. I haven't planned right now to do any live streaming. I haven't done a live stream event like off my phone from the field, but I might try one if I'm able to get somewhere close and I have a good connection and it looks like it'll work. I've never done that before. It'll be just a shot in the dark. So maybe just kind of keep my channel on your notifications list, and if you just see that I've gone lives at some point, we can see how that goes. But it probably won't have moderators. I won't be able to interact as well because if I'm out in the field, it'll just be on my phone. So we'll have to see how that goes. But at any rate, that's sort of the idea. But while I'm gone, I've got some videos that I'll be sending your way. Those road cut videos, I'm recycling a few old ones that have kind of fallen by the wayside, that were launched early when the channel was quite small. So look for a few of those. And also yesterday I launched a really good interview. I thought it went really well with Greg Stock, who is the Yosemite National Park geologist. I met him about a decade ago. He had written the Geology Underfoot book for Yosemite along with another co-author. And when I started working on my books here in southern Idaho, because it was part of the same series, I reached out to him and got some tips and advice. And then I ended up meeting him about a year later when I took students to Yosemite. And he showed us around the valley, showed us some really cool things that were kind of off the beaten path. Just great guy. So if you have time to go through that interview, that would be a really good idea. I'm really enjoying these interview series, and so I'm going to continue to reach out to folks that I think have an interesting perspective or story that they can share with us and continue to do those. So hopefully those are going well. I've heard mostly good comments about those, so we'll have to see how that looks moving forward. And then last programming note, some of you asked me about field trips. The June field trips here in southern Idaho are full. I will promise to get some more dates out and a schedule, maybe all the way through the end of the year, through 2024, and get that out soon so that folks can sign up and plan if they want to join me on some field trips. But basically, I need to get through May and this big Iceland trip before I can turn my attention to that. But look for something in June. I promise sometime in June I will get some other field trip dates out for you so you can join me somewhere. Okay, so let's go ahead and switch gears to Kilauea for a few minutes. As many of you know, because I've done a few updates over the last week or so, there's been some activity near the summit of Kilauea, mainly on the south side and in this zone here, the Upper East Rift Zone. Most of the activity has been in the form of earthquakes along with some ground deformation. And so you can see this date here from April 27th to May 2nd. We had earthquake swarms in the region, clearly delineating the region where the magma was intruding. This did not result in an eruption, but it was significant enough that they actually closed. I don't know if it's still closed as of today. I haven't checked, but this Chain of Craters Road, this is the road that takes you from the summit region of Kilauea down to the coastline. It's spectacular. There's fantastic geology all the way down it. But I think the concern was, hey, if we have an eruption in the Upper East Rift Zone that takes out the road or blocks the road, and we have visitors to the park down on Chater Craters Road, that would make it quite tricky in terms of getting them out of there safely. And so out of precaution, that road was closed for a while. It might still be closed. I forgot to check. I apologize. But this was the concern. And moving forward a little bit, let's go to the latest update from the USGS, and then I'll show you a couple other graphics as well. So this is yesterday's update. They're a few hours behind us, so today's update's not out yet. So the volcano's not erupting. That's the most important thing to say. But unrest continues in the Upper East Rift Zone and in the summit caldera area at the south end of Halemaumau. So they've had elevated earthquakes, up to about 250 earthquakes in a 24-hour period, which is an increase over the preceding day. So I'll show you here in a second. There was a bit of a lull a few days ago, but then the earthquakes actually picked back up over time. Most of these are in the Upper East Rift Zone, averaging 2 to 4 kilometers in depth, magnitudes mostly below a 2, but there was one 3.3. And I think here's the analysis. Magma continues to pressurize the system beneath Halemaumau, the summit caldera, and the south side of Kilauea and Ke'anakakohe crater, activating seismicity along faults in the Upper East Rift Zone. So these two locations are up near the summit at the upper end of the East Rift Zone. At this time, it's not possible to say whether this increase in activity will lead to an intrusion or an eruption in the near future, or simply continuous seismic unrest at depth. Changes in the character and location of unrest can occur quickly, as can the potential for eruption. And that's kind of the same thing we have going on to some degree in Iceland, right? We're not seeing the earthquakes in Iceland, but we're at a crossroads where an intrusion, an eruption, or possibly just continued ground deformation and or earthquakes might continue for some time. So here's the earthquakes over this is the past week, but I'll show you a couple different views of this. So here is the summit region of Kilauea, the caldera at the top. This secondary crater here is the Halemaumau crater that sits inside the larger caldera. This is the South Caldera Zone, so you can see some of these quakes that we've had here. And then this is the upper part of the East Rift Zone. You can see a few of these older pit craters and vents along the East Rift Zone. This is Mauna Ulu, a shield volcano that was formed in the late 60s, early 70s. You can see how big of an expanse that eruption covered that went on and off for about 5 years. But this is the area of concern, this Upper East Rift Zone here. They did run some INSAR, so some passes with the satellites to detect ground deformation. This graphic here shows both the earthquakes, which is the little circles, excuse me, but also with these bands of color here. This is basically showing how much the ground is swelling. So they do a pass over it with the satellites. This uses radar. Then they do a second pass over it sometime later, and that shows them how much the ground has moved up or down during that period of time. And so you can see here, each color cycle represents about 1.5 centimeters of ground motion, indicative of inflation as the magma reservoir pressurized during this time period. So one other piece of evidence that we use to indicate that ground swelling and uplift is taking place in addition to GPS measurements is this INSAR data. And then this is the past week. Past week for Kilauea. So here you can see, make that a little bit bigger for you, all the earthquakes that have happened in the past week from May 2nd up through today. There's the summit region there. East Rift Zone extends down this way. So this Upper East Rift Zone summit region is where all these earthquakes are occurring. These are color-coded by depth. The size of the circle indicates the magnitude. So the reds and oranges are very shallow. Yellows, greens are a little deeper, and then the blues and purples are deeper still. And so you can see the pattern of seismicity caused by this magma intrusion. If we look at a cross-section through that area, we can see where those earthquakes are clustered with respect to longitude near that summit area around Kilauea. These are the Pahala quakes over here, further to the southwest. These have been interpreted as the actual magma plume coming up and sort of running into the base, if you will, of the crust there. This odd one out here is sort of a one-off, but interesting one earthquake out there offshore at a deeper level. And this is a nice plot showing the earthquakes that have occurred over the past week. Now this is what's interesting. Now look here, May 2nd. I think I did an update that day. That was a week ago, last Tuesday. I think I did 2 updates that day. Didn't I get super sassy and do a Kilauea and Iceland update the same day? That might have been that day. But the point here is that we had almost 300 earthquakes in that day. They dropped down, and over the weekend, I suppose, the 4th and the 5th, things were quite low, but they've ramped back up in the ensuing days. So here we are on the 7th, and then yesterday. Today's earthquake total is quite low because the day's just kind of getting started over there in Hawaii. Undoubtedly, this one is very likely to end up right near this 200 to 300 earthquakes per day range. And then the red line shows energy from the earthquake. So when you get a lot of earthquake, cumulatively, that's a lot of seismic energy. So big earthquake days are shown as these big step ups in the cumulative energy produced by the earthquakes. This is a plot of the same earthquakes, but showing depth over time. So here's last week, last Thursday. Here's today, just getting started. And again, you can see that lull, right? Lots of earthquake activity, seismic unrest, and then it kind of dropped down. They might have opened up the Chain of Craters Road during this time because of the lower earthquake risk. But starting around, between May 6th and 7th, you can see everything really starting to pick back up. And that's kind of where we're at right now. So hard to say where this is going to go moving forward. And then just to give you a little bit of perspective over the past month, here's the same graphics, but this is for the entire month. So this goes from April 9th to May 9th. So there's total earthquakes in the area. Again, you can't even really see the summit region with all the earthquakes there. And this is almost 5,000 earthquakes in a month period for this area. There is the earthquakes plotted up with depth. So you can see these shallow quakes near the summit region here. And then as you head down the East Rift Zone, they start to trail off. And then here is the big spike, right? So we really weren't having a lot of earthquake activity until late April, when we got this more, things increased 3 or 4-fold in terms of earthquake numbers, frequency, dropped down for a couple days over the weekend, I suppose, but things are back up to a bit of an elevated state here. And then there, of course, is the plot with time. So you can see the lull that came in this little window here, another lull here. But overall, significant seismic unrest related to that intrusion. So, and then last thing I can show you here, this is kind of fun, is using Google Earth. We can actually see where these earthquakes occurred. So here's again the Kilauea summit. The little village of Volcano is right here. And this is the East Rift Zone. This is one of 2 rift zones that emanate from the Kilauea caldera that define the volcano itself. These are places where eruptions are frequent and expected. And of course, in 2018, we had magma move down the East Rift Zone and erupt in this lower section here and take out part of this neighborhood and ultimately destroy about 700 homes. It also went down to the coastline and added some real estate to the eastern tip of the Big Island. So this is the East Rift Zone, but I'm going to take the East Rift Zone off just so we can see the earthquakes in all their splendid glory here. So there's the East Rift Zone off. Let's take the caldera rim off too, just for kicks. So here's the area we're going to look at, and then we'll just animate this to add the earthquakes in. So here's the earthquakes over the past week, May 2nd to 3rd. Lots of earthquakes, but then as we went into May 4th and 5th, not so many. That was that lull. And then as we get here into May 6th, you'll see those start to pick back up. The South Caldera cluster, and then the stronger cluster here on the East Rift Zone. So there's earthquakes through yesterday and then up through today. So that's the earthquakes there. and I think there's a way we can even, and there's the full suite of earthquakes over that period, just plotted up for fun. The other thing I thought it'd be fun to show you here, this might knock some of your socks off, is, and I'm no Google Earth expert, so let's full stop there, but you can add, when they're available, you can add geologic map overlays to Google Earth. So this is the geologic map for the Kilauea summit region. So you can see the caldera here, Halemaumau here, and then the numbers in each of these zones correspond to the dates of those eruptions. So this part of the caldera floor was covered by lava in 1921. This map is more than a few years old, so some of these are quite outdated, but this was the last published map of this region. Probably a tricky thing to do because it keeps changing. And it really comes into its own when you're kind of dealing with areas off of the summit area, some of these places where the eruptions are a little bit older, like over here at Mauna Ulu. I mentioned that was an area that erupted from 1969 to 1974, so you can see some of those flows there. Pretty handy. And you can see the faults. So this is part of the Kauai fault system that sort of links the southwest rift zone to the east rift zone over here. Anyway, some of you might find that pretty cool. And if you have a USGS file, a geologic map, you can sometimes get these as KMZ files so you can drop into Google Earth. So fun stuff, all sorts of good stuff here. I'm not an expert on how to do that though. So okay, let's switch to Iceland now, which is probably what many of you are here for. So what's happened in Iceland? Well, here's the current state of affairs. The spatter cone that we've been tracking for quite a long time now, for several weeks, maybe more than a month. According to the Met Office, as of today, this eruptive phase is officially over. They did an overflight yesterday. They didn't detect any new lava coming out of that crater, and so that eruption is considered over. Here's the current view of the spatter cone. Just it's degassing, the lava field's degassing, but it's not emitting the spatter. The lava's not being thrown out of the vent. And so it looks like it's pretty much over. One thing that did happen though last night, so remember that this is a spatter cone, but we did have within it a secondary nested interior spatter cone that developed over the last week or so. And apparently that actually collapsed last night. So here's, I'm not sure exactly what time it is, I could figure it out, but here's that inner spatter cone, and you'll actually see part of it collapse here on the left side. So there was a little bit of glow last night, but that's just lava cooling, not necessarily lava that's being pumped from depth and reaching the surface. But what you'll see here, there it goes, there's a little collapse there, and then a bigger portion of the cone collapses down. So why did that happen? What's going on there? Well, remember the lava is being pumped to the surface by gas pressure. Once that pressure is no longer there, you'll get material collapsing down into the vent. You've got the material cooling over time, and so that's a volume decrease. As things get cooler, they contract, and so that will also cause some collapse. And undoubtedly, some of these little collapses are also triggering and being measured as small earthquakes in the area. So some of the earthquake activity we see there, especially the very shallow ones, might be related more to the collapse versus something happening at depth. So the end of the cute little spatter cone is pretty much here, but there's still a good chance, and we'll get to this at the end of the update, that like a phoenix, it could rise from the ashes. This thing could potentially have renewed activity and burst forth and have very vigorous eruptive activity. We'll just have to see going forward. But for now, this is no longer an active volcanic vent. Thanks as always to Amanda Jo for sending me some of this great information on a lot of these links. She really helps me craft and put these updates together. Incredible time save for me to have her send me some of these ahead of time. So this is from the Icelandic Research Group, the university. It's in Icelandic, but there's a little bit of English here, which is helpful. But this is just a summary of the eruption that began on March 16th and continued. This, I think they've taken this up to about April 30th, so essentially the end of this eruption. But this first graph here shows the total area covered by lava. And what you can see here is because these fissure eruptions start with a bang and have high effusive rates, they're erupting a tremendous volume of lava initially. Much of the lava area and volume is achieved within the first 24, 48, or 72 hours of the eruption, even though this thing went on for not quite 2 months, but 6, 7 weeks. So you can see here the lava area was pretty much established by within a few days of the eruption beginning. And then not much else was added. Of course, some of you will remember that when this thing started, we had a lobe of this flow that went up against the berms, was moving southeast towards the ocean. There was concern it was going to reach the road and ultimately reach the sea. As it turned out, the lava supply wasn't sufficient to do that, but it was a concern. So they've nicely plotted up the lava area over time. The second graph here shows lava volume, so the total amount of lava that was erupted. Using different bits of data, satellite imagery, and other remote sensing methods. And so you can see that probably even most of the area was added early on, but the lava volume still increased for a while. So what that means is that the size of the lava field was set, and we only added more lava volume by injecting more lava just beneath that crust and inflating it. And I've shown you some graphics that the Met Office has put out over the last few updates that actually shows the lava field growing vertically as more lava is injected beneath that solidified thin crust on the lava flow. It allows it to grow. So it's added volume not by spreading out, but it's added its volume by inflating, just like a balloon. And we've got our total numbers here, a little over 6 square miles area, a little over 34 million cubic meters of lava erupted. This is the lava discharge rate, so how much lava was coming out per second, cubic meters per second. And you can see initially this thing was off like a gun, pumping out tremendous amounts of lava during the early phase of that fissure eruption. And then, they show it stair-stepping down, but really you could connect these points with more of a smooth kind of curve here. And you can see the lava rate dropping over time. And then we get down here to where it's like, down to 1 or 2 cubic meters per second. And of course, as of today, it's pretty much done for. And then the inset here just shows the early phases, the first 24 hours or so of the eruption on March 16th to March 17th, how it started out at about 1,200 cubic meters per second. And then it was, only a third of that within 4 hours, and then it just dropped down to these lower rates here. So this first part goes off the scale, goes off the graph. This shows you the full extent. Notice this only goes to about 30 cubic meters per second, whereas this inset graph shows how high it truly was, up to 1,200 cubic meters per second. So nice work there. Good job. The Met Office update from today. There it is, the headline, no activity in the crater. This eruption is over. So that's as of the Met Office. Remember though that just because the eruption is over, this specific phase, this chapter in the eruptive history is over, but now we just anticipate and wait for the next eruptive phase. We know we've got a tremendous amount of magma stored in the subsurface. That's going to get to the surface at some point. Or it could be injected and form an intrusion. So no activity over 24 hours. They're continuing to measure land rise and elevation under Svartsengi. Rate of magma accumulation remains the same. Probability of a new magma flow and another eruption continues to increase. The warning time could be very short, and the risk assessment's basically the same. So they flew a drone over it last night, and there was no activity seen in the crater. And so that's how they're calling it. This eruption, which lasted almost 54 days, is over. However, there's 13 million cubic meters of magma that are sitting in the subsurface that have been stored there. And this is a nice little plot that shows how that has taken place. So these other colored lines over here are the other eruptive phases that we've seen over the last few months. I won't go into too much detail on those, but the red line here, this is where we're at now. So we're at day 54 or so. We've accumulated about 13 million cubic meters of magma. And the big question, of course, is will this line continue to trend upwards without an eruption, or will it erupt very soon? The stars here are eruptions that took place. We've had 4 eruptions from this area, and then the 2 squares are the intrusions that took place here. So some interesting information there from the Met Office. If we start to look at the earthquake activity over the past week, there was a cluster of offshore earthquakes, some of which were, in the magnitude 3 or so range. There's a 3.2 near this small little rocky island called Eldi. I addressed these in a previous update. There is nothing to believe that they're magmatic in nature. They seem to be just part of the plate boundary tectonic processes. If we zoom in a little bit more closely over the past week near Grindavik, the most significant earthquake of the bunch was a 1.7 over here, just west of Grindavik, and then maybe that one there's 1.6, and that's pretty much it. The colors are coded to when they occurred, so red most recent, yellow, green to blues within the last week. So you can see not a lot of seismic activity. The clustering here, especially some of these, let's see. So some of these deeper ones, again, as the eruption starts to wane, you can get collapses both within the cone itself, but even deeper into the system. And so some of these might be related to that, or they could be related to pressure on the system, right? Magma maybe is in that zone, and as it gets pressurized, it's pushing out on the rocks and breaking rocks. But nothing, of course, here, not nearly the degree of severity in terms of magnitude or frequency that I would expect to see if a new vent were to open. If we get an eruption from the same vent, that might happen with very little earthquake activity. Similar plot for the past 2 days from the Met Office. So you can see sort of the timing of these things over the last 2 days. Wednesday was a pretty busy day earthquake-wise, and then today not so much. Not sure if the weather played a little bit of a role in that, in affecting our ability to detect those. But there's the last couple days, just one above a 2, one today that was right at a 2. But nothing much from the earthquakes that's really speaking to something big taking place. Last 24 hours, if we add all the earthquakes, kind of looks awesome, right? Like, oh my gosh, that looks pretty incredible. But these are pretty small earthquakes. If we look for anything over a 2, there's just 1. If we just add everything over 1, there's maybe 5 or 6. But this is going to be, as we move forward, this will be maybe the main thing to look for. If we're going to see a new vent open somewhere, this would be the data that would be most helpful, is to see earthquakes probably above magnitude 1, clustering in a location, especially if it's going to be a new vent, not along this trend here. But everything seems to be occurring along this northeast-southwest trend from that dike that formed way back on November 10th. So some of these outlying quakes and some of these other areas and over near the Fagradalsfjall area are just probably related to they're experiencing some of the stress of this magma intrusion, and so that's causing these tiny little cracks and breakages in the rock and triggering these very small earthquakes there. So that's the earthquake data. If we go to the GPS data, which we've been tracking for a while, here's our Svartsengi data, and this shows this plot on the bottom here in red shows the uplift. You can see this little elbow here. So after the March 16th eruption, there was some uplift of the area, but very slight, almost, not much at all. But then in early April, it started to accelerate, and the uplift was more significant over time. There's been a few lulls in this trend, but here's where we are right now. So the uplift trend seems to continue. If you dissect any given 1 or 2 3-point cluster, you can interpret it any which way. That's why we tend to take 2, 3, 4 days at least of GPS measurements in aggregate and see what sort of trend those project. So the station is moving up, the station is moving to the west a little bit, and the station is moving to the north. And so if you think about that in the context of getting over to Iceland, this station sits, actually I could pull up the stations. The Svartsengi station is right here, and if it's moving to the northwest, that indicates the magma body is pushing it up, but also pushing it out and away from the area of inflation, which is presumed to be somewhere about here. So all the stations pretty much show the same trend. When I was looking at these, nothing too different there, but those are a good one to keep checking as well. And I'll put links to all these in the description as well. Another way we measure ground deformation is with that INSAR data, like we just showed for Kilauea. And this is kind of a bit tricky because it's covering such a big area. But here is the Reykjanes area. So this is just north of Grindavik. And so you can see that bullseye pattern. What's interesting to me is that we've seen these before, but the center of the uplift was a skosh to the west, and this shows it a little bit further east, maybe a half a kilometer or so, maybe a kilometer at the most to the east. Again, not probably nothing to rely on just based on itself, but an interesting little trend. So has this magma storage zone shifted to the east? Is there a little bit more uplift to the east than when we've seen prior INSAR data, which showed it a little bit further to the west? I think we'd need to see a couple more of these to really see if that's true. But you can see, nonetheless, the ground deformation is totally showing up on the INSAR data. So that's some of the data I have for you. Let's look at a couple news stories that Amanda Jo has sent. But let's quickly maybe run through a couple different scenarios. So what's going to happen? That's what everyone wants to know. Everyone wants the geologist to make some big, awesome prediction about what is going to take place. And of course, no one knows. We don't know for sure where this is going to end up or how this is going to go. But let's look at the most likely scenarios. So probably one of the most likely scenarios is that the magma continues to intrude and inflate in this area here. And it takes the path of least resistance, which right now is the pathway over here to the east to this dike system. And it erupts through this existing fissure. Let me get rid of some of this junk here. This existing crater and fissure that opened up on March 16th. In other words, this guy or gal or person, this vent. That's one possible scenario, is that the eruption resumes its activity through the existing vent. Second possibility is it opens up a new vent. So then this one would not be the primary location, but maybe it's something to the north, possibly along the same trend. Maybe it's one of these other fissures that or vents that opened up in the December eruption, maybe in the February eruption. Or this is not ideal, but if it's something further south from the January eruption closer to town. So that would be scenario number 2. However, with scenario number 2, we'd expect to see earthquakes, right? So if this magma is going to reoccupy some of these partially solidified, partially plugged up vents and conduits, it's going to have to break some new rock. We're going to see some earthquake activity that precedes that. If it comes through the vent that just died out today, then we might not see much earthquake activity at all associated with that. A third possibility would be that there's no eruption, so nothing breaks through to the surface, and instead some of the magma that's pressurized underneath this area pushes into the rocks, possibly to the east, possibly in some other direction, and forms an intrusion. So it would maybe take a pathway into the rocks at depth in the surrounding areas and push some of that magma into a new space, finding it more storage space for itself. If that were to occur, an intrusion, we would definitely see a very strong seismic signal or earthquakes that would come from that. And then I guess the fourth possibility would be that we just kind of it keeps doing what it's doing right now, which is inflation continues at a steady, more or less steady rate, but there is no eruption and there is no intrusion. Now that fourth scenario isn't really sustainable. It can't keep doing that indefinitely. So it'll be interesting to see what takes place over the next couple of days. I would be really surprised if I came back from Iceland on May 30th and there had not been either an eruption or an intrusion as indicated by earthquake activity. If that took place, I would be very surprised. So I guess expect an event, whether it's an eruption or an intrusion. Expect it to be fairly soon. I would say within the next week or two is a good time frame. But where, when, how much are all things that no one knows for sure. So interesting. Okay, so let's look at a couple of news stories that that Amanda Jo has sent me. So this one here is from, let's see, now I've lost where I was with all these. So this one just talks about the eruption has ended, 13 million cubic meters of magma, and Benedict Olfigsen with the Met Office, we're in exactly the same position we were in the days and weeks before the last eruption. He thinks the next one will be most likely in the same area, whether it will be a magma intrusion or a volcanic eruption. And why does he think it'll be there? This has become the weakest point, he says. And so then he talks about how the system is changing, that we can't take what happened in the past and use that with a lot of certainty to predict what's going to happen moving forward, that we have to treat that the system is evolving, developing, and we have to be on our toes and see how this changes and develops. And I totally agree with him in that respect. And then there's an article from Arman, I can't remember his last name. It's got to be right here. Oh, Herskudsen. So this volcanologist has been maintaining for quite some time, since really the early stages of this eruptive activity back in the fall, that we were going to see at some point the eruption vacate the region that it's been in. So all these regions over here, we've now seen 4 eruptions and 2 intrusions in this area, but he continues to maintain that it's going to move over here to the Edvard area. And it may do that at some point. Could it move there at some point? Absolutely. Anything's possible. But we just don't see any signals. There's no magma movement in this area. There's no seismic activity. So I don't know how many articles I've seen where he maintains this, but I'll give him credit for sticking to his guns. So here it is. He believes the next eruption will be at Edvard. More has been added to the magma chamber, and that's been the case in these eruptions. It can start erupting at any time, but with such shortcomings that we will definitely start to feel it on seismometers before the closing of this hole that's at the southern end of the fissure. The change, let's see, I believe that it will start to get shorter in Elverp, which is the middle of the plate divide in the area. So, and then there's, of course, Google Translate issues here. This is funny. Volcanoes are the best area for eruptions. Agreed. Volcanoes are one of the most favorable areas for volcanic eruptions. Newsflash, there you go. Yeah, that's just a Google Translate thing there. So the point here is that this gentleman and this volcanologist is pretty adamant about it moving here, which it might. I just think before I were to say something like that, I'd want to see some evidence that it's moving that way. But we just don't see that just yet. All the eruptions have been here. The magma's clearly established conduits and a plumbing system for these eruptions that have occurred here. We also know that we're not that far away, and we know we have a connection to the eruption areas over here from 2021 to 2023. So seems just as likely it could move to this area as to this older crater series that hasn't had any activity or eruption for hundreds of years. So there's that bit of news for you. And then moving on, This is more about the human side of things. And so if I've got this right, and thanks again to Amanda Joe for sending me this, there's going to be layoffs in the town. I think the crux of this article and the next one I'm going to show you is that the the characteristic and the evolution of this town are definitely in flux, right? This was a town of 10,000 people. There was a community there. All this that went down over the last fall. Now there's probably only a few dozens of families residing there full time. A lot of people have sold their homes, and they're going to have to change the nature of this community in terms of the infrastructure of the town. Um, they just don't. It's going to be a different kind of town. It's not a town where people live as much. It might be a town where people work, but maybe not living as much and having schools in the community there as much. So I'll put links to all these on the in the video description. This article here talks about that there were 766 applications to have people's homes purchased by the government, and they've already approved and processed about 528 of those. So a large number of all these homes and homeowners have pretty much made the decision that they're going to cut their losses. They're going to sell their house to the government at the rates that were agreed upon and voted upon, and look for accommodations and housing elsewhere. And that's certainly the case with our very own Mandy Joe there in the live chat, who's one of our moderators. Her and her husband have, I think that's finalized. She can chime in on that. They've sold their home and were able to use those funds to purchase this other home they have in a different community. So a sad state of affairs. It's sad to see what's happened here at Godindevik. I think we were very sensitive when this started in November. I know I was, and maybe now we're just far enough past it that it feels more kind of just numb, I suppose. But I do want to give a little bit of empathy here to just the tough decisions that people are having to make there, whether to sell their home or try to stay. How do you maintain some sense of community for this fishing harbor and the industry that's there? And it's very difficult. So anyway, this just kind of goes through some of that real estate and business transaction. And then to end on a high note, Amanda Joe, thanks for sending me this story. I thought this was kind of cool. This is sort of a feel-good story. So there's a 13-year-old boy from Godindevik, and he is good at drawing and art. And he has been spending time drawing people's houses. So realize that these houses, we don't know their future. We don't know how long they're going to exist. And so he's done a nice job drawing some of these homes that still exist in Godindevik for these homeowners. It looks like he's received about 20 orders for these, people asking, will you please draw my house, so that they kind of have a memory of it. I think it's a great idea. And so it's giving him something to do. It's hopefully a little bit of the healing process to the whole thing. The video story is in Icelandic, so I wouldn't be able to help you understand it. But yeah, he just did it, drew a picture of his house and gave it to his mother for Christmas. But then kind of word got out, and people wanted him to do it for them as well. So awesome news there. Kind of a fun twist to the whole thing. So excellent. Anyway, I think that is about where we're at. And so let's go ahead and go to any questions you might have. So that was a good 50 minutes of me kind of running through a bunch of stuff. And let me grab some of the questions Amanda Joe has sent me. So if you have questions for me, I don't know how many I'll be able to get to. She sent me a page. I think I'll get a second page. We might be able to do 3. We'll have to see. And we'll take it from there. So hopefully everyone's doing okay on the live chat. Let me just make sure a couple things are going well here. Okay, so let's start with the first question here then. Thanks for the folks who have sent this in. And I'll do the best I can to answer it. Of course, if I can't, I will say as much and we'll just try to figure out how we might figure it out. From Keith Dowsett, why did the earthquakes around Grindavik Northwest and Sunukur increase when the eruption stopped? I think Keith is referring to, let's pull up the earthquake map. Well, someone might want to see the Kilauea stuff. Let's pull up the earthquake stuff first. Yeah, or maybe the better one to look at is probably this one, right? So we did have over the past week, and notice those are in more of these blue colors. There was kind of clusters of earthquakes here. So why did some of these earthquakes pick up a little bit? I think it's probably most likely related to you've got this magma storage zone here. It's exerting pressure in these regions, and these rocks are already pretty weak. And so if we go here, oh boy, let me get rid of some of this. This is messy. Let's get rid of a couple things here, clean this up for you, just to make my point. Let's get rid of all the berms. We don't need those. And let's get rid of all the eruption sites. So we'll make it really clean. Remember we had these grabens, right? So we had two fault zones that showed up, and one was from, I don't even remember the dates anymore. Sorry about that. But there was this eastern graben and this western one. And so lots of fractures and faults in these zones. And so I think this cluster we're seeing on this side of Grindavik is related to, these are just easy trigger areas for these earthquakes to occur. So whether it's pressure from the magma body, or maybe like up in here around the vent area, it could be lava draining down and the eruption waning. Any of those places are just easy locations to trigger earthquakes because the rocks have already been stressed, fractured, they've already broken, and it's easy to trigger more earthquake activity there. So that would be my best answer to that. From Sus, I hear a lot of discussion in chats about the graben and what might be expected next. Would be interesting to see what his thoughts are on that. Oh, good timing. I don't know which one you're referring to exactly. So these grabens form above propagating magma dikes. You'll get a downdrop in the middle and elevated rims on the sides. I've shown these in prior with prior graphics. So what might be expected next? I mean, the grabens are clearly weak zones, but we have a clear pathway for this magma chamber or storage area to erupt over here, where we're seeing this existing eruption take place. And so it seems more likely, and notice that lies kind of like right on, that vent opened up right along the edge of one of these grabens. So these graben zones, these faults, all these faults and fractures are weak zones, pathways, conduits for the magma to move in. Could it follow one of these and erupt somewhere in here? It absolutely could. But for now, with these established pathways where these vents have opened up here, seems more likely that it will follow those again. That magma in the conduit might still be molten. It might be kind of slushy or crystal mush, but that still is less, that sometimes is easier pathway than breaking existing rock. It sort of depends on the viscosity of the magma at that time. From Connie's Little Corner, what are your plans for while I'm in Iceland? Yeah, so I'm there for about a week or so with students. We spend, we're staying somewhere over here. We'll spend 3 or 4 days in the Reykjanes area, kind of checking out different geologic sites. Then we'll head down the south coast, do a glacier hike over here. We'll stay about here and get as far east as the Glacier Lagoon. So we'll spend a couple more days checking out geology sites and locations here. Then when the students fly out on the 20th, I've got 3 days. Kind of depends on what's going on. If there's obviously an eruption and excitement happening, I want to focus on that. But if nothing super noteworthy is going on the Reykjanes, my plan is to head up to North Iceland, where I've never been, and look at some of the features and check out some of the geology in this area. So I'll take a couple days going up there. Then I'll work my way back down. I'll meet with Amanda Joe and her husband for dinner on the 23rd. And then I've got some YouTube viewers flying in on the 24th, and we'll do a similar tour to what I did with the students, a couple little tweaks here and there. One cool thing we'll get to do, I think, unless the eruption is too juicy to ignore, hopefully going to get out to the Isle of Heime and look at some of the cool geology there. This was a big eruption in the 70s. You can see all the lava here, the port. Never been there before, so looking forward to that. So those are my plans for Iceland, at least as of now, but could all get significantly changed depending on what happens with the eruption. Joanne Kellum, my wife loves her hat, by the way, Joanne. Thank you so much for sending that. I think she's going to send you a card or something in the mail. But her question is, lava recently moved in tubes beneath the older flow east of the L12 berm. Will it matter to geologists 20,000 years from now that the lava at the top of the stack is a little bit older? No, not really. We're kind of used to that. When you work through volcanic stratigraphy and layers of lava flows, you have to get rid of and sort of ignore some of those time-tested geologic principles that, oldest rocks are on the bottom and youngest rocks are on top, because lava flows just follow topography, and so you can have things sitting higher that are actually older and stuff that's lower that's younger. So 20,000 years from now, hopefully the geologists will be on top of that. If not, geology's gone really wrong sometime in the future. Ann Umphrey says, I would love to have Shawn discuss Snowball Earth, actually early Earth history. Yeah, I can do that at some point. I think I discussed it a little bit with the video I did out on Antelope Island, but I haven't done much with it. That would be fun. It's an interesting topic, one that I'd like to learn even more about. So thank you, Anne, for that idea. From Britta, will you meet Gylfi in Iceland? Think this would be fun. Yeah, he and I are talking. Not sure yet. I'd like to. I don't know where he's at. I think he was on the Reykjanes, in the Reykjanes area. It might still be. But at some point he was going to go back up to North Iceland. I just need to circle back to our back and forth emails and see. Because I think if, I'd like to do the interview with him. He wants to do it. On one hand, it's kind of easy to do it by Zoom, which means we can be anywhere. Logistically, that's probably easier. But I think it would also be fun to do it face to face, and I could probably just do that with like my iPhone and just like have a conversation with him with the iPhone kind of up and just do an interview that way. So we might do something outside. I'd like to do that, but my time's kind of limited. I've got these 2 trips and just a little bit of time in between. I think when I go next year, I'll probably try to plan some more time to do some of these other things. Ricky Brown wants to know, do the black lava fields eventually redden simply from oxidation of iron, i.e. rust? Yeah, absolutely, Ricky. These lava flows that are nice and fresh and black looking, whether they're in Hawaii or Iceland, will eventually oxidize. They'll start to establish lichen and microbes that start to grow on the surface. After a while, they'll be covered in moss. But initially they'll be kind of black, but they'll eventually weather to more of a reddish brown color. It all depends on the climate of the location, and certainly the wetter and more tropical the climate is, the quicker those flows will tend to oxidize and weather. Connie's Little Corner, question number 2 for you. How much, if any, effect does the shifting of the plates impact upon the path of the magma? In general or at this location? Guess I don't know exactly. So the plates are fundamentally driving the volcanic activity we see here north of Grindavik. And that's why we see these strong northeast southwest trends just in the topography. These are prior eruptions that have taken place in this landscape. And of course we can see that even with our fissure eruptions that have opened up here. So the way that the plates are spreading is opening up fractures or cracks or faults in the ground, and the magma is exploiting those cracks as it comes to the surface. So the shifting of the plates absolutely has an impact on the path of magma migration and movement, if that was the question. So yeah, good question there. Okay, so that was question sheet number 1. Those are some good questions, team. Well done. Let's go to question sheet number 2. Let me just check over, make sure everything's okay on the live chat, make sure Amanda Joe hasn't messaged me something I forgot or did. Sweet. So, all right, let's go to the next set of questions. Thanks for sending these in, team. We're all learning together. Okay, from Elaine Jones, lucky Elaine Jones, who I will see in Iceland in a little over a week. Do hotspot magma intrusions manifest themselves differently from spreading ridge intrusions? No, not near the surface. So a great exercise to compare here would be to take Hawaii, which is solely a hotspot, and then also take Iceland, which is a hotspot but is more, more dominantly a divergent or spreading ridge. Now at depth, Elaine, I'm not sure. So as magma's coming up 10 kilometers down, and if that magma stays underneath in the crust and cools and crystallizes into an intrusion, I'm not sure. I don't have a lot of expertise there, but certainly as they come closer into the shallow crust, they're going to follow fractures, rift zones. We talk about rift zones in Iceland. We talk about rift zones in Hawaii. They're inherently the same, even though they're in slightly different tectonic settings. So intrusions will look the same. Intrusions will generally be one of 2 types, and this is incredibly generic. And I think I did a whole thing on intrusions at one point. But if it's a vertical conduit that's transporting the magma to the surface, that will be a dike. And if it's more of a horizontal or tabular shaped body of magma, those are for storage, and that's what we sometimes call a sill. And we've of course used this term sill here for this intrusion. Probably isn't the best word because we don't know exactly the geometry of the thing. So I've just been calling it a storage zone as of late because I feel like that's a little bit more generic. So great question. Hopefully I answered that okay. Sarah Moore wants to know, what's the ratio of intrusions to surface eruptions at Kilauea? How common are these failed intrusions versus actual eruptions in this semi-recent phase of activity? Shoot, I just read this somewhere, Sarah. I'll give you some numbers, but don't quote me on these, but these will be probably in the ballpark. I think the ratio of intrusions to surface eruptions, both at Kilauea and probably Iceland, is something like 5-to-1. So for every 1 eruption, magma that makes its way to the surface and erupts through a volcanic vent, you might have 5 other events that are failed eruptions or arrested dikes, magma that's propagating to the surface and then doesn't quite make it up to the surface all the way. And I was thinking I might have a quick graphic here that might show some of this. Maybe. So we know they look like this. So this is what they look like, oh boy, at the surface. Right, so here's a dike cutting through the rock layers here. But they can also be arrested, right? So a dike can come up and stop. Depends a lot on the rocks it's propagating through and its inherent properties. Not all the rocks are the same. They'll fracture differently. Some will be more resistant. This goes back to the graben thing too that we talked about. Why is there a graben in those areas? Because presumably they are sitting above parts of this big dike that formed on November 10th that didn't make its way to the surface. But hopefully this is making sense a little bit. So if I had to answer your question more specifically, I don't even know what I'm looking for now. Just a whole bunch of pictures. Anyway, to answer your question more specifically, it would be probably something like 5-to-1 as a ratio. So, yeah, I thought I had something for that, but looks like I don't. So, or I can't find it right now. Another question from Sarah Moore. Look at you. Do you think that the rate of uplift will increase now that none of the magma is being wasted at the surface? I don't think so. I mean, there was very little magma. What she's asking there is, are we going to see a stronger signal? Let me see if I can get myself together here. Looking at the GPS data. Here we go. Well, let's go to the one we want here. This one. So now that this eruption is quote unquote over and none of the magma is getting to the surface, will we see the trend of uplift increase? We could. That is a possibility. I just don't think a whole lot of it was escaping over those last few days or maybe even week or two of the eruption. It was very low rates, like 3 or less cubic meters per second. And we know that a far greater volume and influx rate was happening in the subsurface. So we might, but we might not. So if you don't see any marked increase in inflation, don't be surprised, but it could uptick a little bit. So from Octavia Newson, so the plate is spreading apart horizontally. How much could the land expansion affect the amount of magma stored and thus the time to an eruption? Yeah, so that's a good question there. So the idea here would be as we spread, as the plates are spreading, but remember, these plates are spreading slowly. On average, it's like a centimeter per year. So it's not like the plate motion is creating a lot of space year in and year out. But does it create space? Yeah, and that sometimes is what triggers magma to be initiated. As we take pressure off of that, it causes it to rise. Might make it to the surface, might not. Could the land expansion affect the amount of magma stored? Yeah, so if you can put more magma into storage, if you can keep more of it, if you can create more space underground, then you're possibly prolonging the time or the date when the eruption might occur. That's certainly the case. However, I think the thing to look at here might be this, and see how much magma we could store in the system before the system broke, basically, and moved somewhere, whether that was the big dike forming event on November 10th or some of these other eruptive events here. I doubt we'll get back to this threshold of 19 million cubic meters of magma. I think we're going to see the system fail and push magma into some space at a much lower location in here. Susie Jones, the December 18th inflation went up to, yeah, I just talked about that. Yeah, this one did get close, right? This is the, wait, I was looking at the wrong one. Okay, let me back up. Sorry, this is the September 10th intrusion, and then the December eruption got quite a bit higher. So I was wrong there a little bit. And Susie's correcting me with this question. Let me get to your question. Do you think we may see this again now that the cone has closed? I don't know, because that was like the first eruptive event. And so you had created some space here. You had some elasticity that probably created some space as well. I mean, it's possible. Is it possible to get back to that threshold? Maybe. I just feel like it's more likely for it to fail at a lower level with these conduits already opened. The December event had to create space to get the magma up to the surface. So you had to break rock through a 4 to 5 kilometer length to get that magma up through cracks to the surface and erupting at the vent there. All these other ones were at a lower level, and so maybe it kind of depends on where it's going to be too, right? If it's going to be in a new location, a new vent, maybe you do get back to that threshold. But if it's going to erupt from one of these existing vents, I think it's at a lower level. So just a guess, just my opinion. Vivid magic. Is there any pattern in the alternation of active and non-active periods for ages? I don't know exactly what that question's asking. I think that question might be asking a little bit about this behavior here. Where's it at? Yeah, this. So if we go to this one here, is there any pattern in the alternation of active and non-active periods for ages? So if we look at the volcanic systems on the Reykjanes, there's clearly a pattern here based on the data we have, but the data is quite limited. It only goes back a few thousand years, but it does tend to show when we get an eruption or eruptive periods, many of these systems erupt intermittently, sometimes at the same time perhaps, during that period. And remember, these periods last hundreds of years. And then there's these quiescent periods that last several hundred, up to 1,000 or more years. And so we're just kind of entering this phase there. So is there a pattern? I'd say there's a crude pattern. How much would we bank on this pattern moving forward? Hard to say, and it's all we have to go on. We're really playing lousy math and statistical games with limited data sets, which is always a bit dicey, but it's all we have to go on. We only know what this system has done over the past few thousand years. We can date the rocks. We know how long the eruptions went on, more or less, and so this is the data that's been compiled, but it's not a complete picture, and so making projections into the future is a little bit tricky. So anyway, yeah, and it could they all be linked perhaps? Maybe. There's some models we've shown here that show at least the Fagradalsfjall and this system. We know geochemically that they're linked by a deeper source that is supplying both of those surface vent areas. How well are they all connected, going from like the Hengil system off here to the east, all the way back over to the Reykjanes Ridge? I don't know that that's been well established, but clearly, at least timing-wise, it looks like there's some overlap there. But realize that you're looking at, that little space there is 500 years. That's an incredibly long period of time. And not all of them were erupting at the same time. So it's messy. I wish we had much better control over how long the eruptions lasted. I mean, we're seeing with this eruption, we've got 4 eruptions in like 4 months, something like that. And it's hard to get that kind of resolution out of the rocks going back in time. It's hard to say, oh, this eruption lasted, 2 weeks and this one lasted 2 days. We don't know that. We get dates from the eruptions, but they have error bars of, plus or minus a few hundred years. And so we just don't have the resolution to really see the exact number of eruptive phases. We can just see kind of when it erupted in mass as a big story, if you will. Okay, I think there's one more question here, and then we'll see where we're at. I do have a department luncheon thing I have to get to in a bit. So the last question here is from Kim T. The lava pool emptied from the most recent eruption site. Where did it all go? I'm assuming Kim is asking about the crater at the surface. So this thing here. Whoops, we gotta restart this. So this thing, the lava pool emptied from the most recent eruption site. Where did it all go? Well, the only reason it had a lava pool is it was being continuously supplied with more fresh lava from the subsurface. So it's no longer, it's still there just below the surface, but it's cooling and crystallizing, and there's not a continual supply of magma or lava into the system. And so you can sometimes, though, get drained back. So you can get some of the lava draining back down fissures or vents. I actually showed that with a recent video I put out for Kilauea at Mauna Ulu. Actually have evidence that the lava drained back down into the fissure, and you can see that quite easily. when you look around that landscape there. That was the eruption that was from the 70s. So hopefully that helps a little bit there. Let's see, where are we at? There's still people hanging in there. Good deal. And one more, let's see. All right, we'll do one more question sheet. Amanda Jo just sent me one more, so we'll do that. And let me just check a couple other things she sent me. Something in the first email link. Oh, a new 360 photo. So let's see if I can find that real quick. Let's see, I'm not seeing it in... Oh, here we go. Okay. Yeah, there it is. So let me see if I can get this pulled up, and we'll see what Amanda Jo has sent me. Oh, this is fabulous. Let's take a look at this. So here is, this is from today too. So this is a 360 shot of our cute little spatter cone. So there you can see what it looks like. You can still see the inner rim of that nested spatter cone, and then where it collapsed here on this west side where it's just kind of rubbly here. So this is pretty sweet. Thanks for sending this, Amanda Jo. So the bigger spatter cone, the rim not as well defined on this sort of northwest side. And then the inner spatter cone, this nested spatter cone where it collapsed there. But you can just see some of the gases coming out through the cracks. Nice view there of the cone. This is the lava field that probably still has lava just below it that was inflating. You can see the protective berms out this way. So there's a couple of the hills as landmarks. Now we'll swing around to the west. Here's the Blue Lagoon and Svartsengi. This is great. Zoom back out a little bit. And so this is what it looks like as of today. Awesome. And thank you to Horder Krislevsen, who supplies these great images. So make sure you check out his Instagram feed. He's got lots of these great drone and other images kind of at work. So other events up here from the December and February eruptions. And then you can just make out the little cone right here from the Fagradalsfjall eruption in 2021, that little kind of plateau flat zone just above the little hand icon there. That's the spatter cone from that eruption. Here's this older shield volcano right here with the summit crater and then these nice sloping sides. So this is an older shield volcano. These flows have gone around. Yeah, just a great image here and great way to kind of get the lay of the land. So thanks for sending that. Okay, last set of questions here, team, and then we'll wrap up here in a bit. Okay, question sheet number 3. Ready, set, go. From Sarah Pieratini, the lava accumulated this last month did so while venting was occurring. Can we expect it to be less fluid than the previous ones? Or the degassing is more localized and happened only under the vent? I got to read that again, sorry. Accumulated something while it was venting. Yeah, so we had magma inflation, right, over this last month. Can we expect it to be less fluid than the previous ones? I still don't get the question. Sorry, the lava accumulated this last month did so while venting was occurring. Yep. Can we expect it to be less fluid than the previous ones? No, I mean, that's partly related to temperature. The dissolved gases can play a role as well. I think the further these flows, the fluidity of the flows as they travel will be related to temperature. Well, it's related to viscosity, but that's what is fluidity, right? The opposite of fluidity. Be related to temperature. It also be related to shear stress. If the lava is going down a steep slope and rolling over itself, it will tend to actually become more viscous because it's tearing itself apart, being stretched, and it will transition more easily into flows. If it's moving along a very slow slope, that's when it will tend to be more fluid-like. So I hope I answered that question, but I don't feel like I did really well there. Didn't quite understand the whole thing. Sorry, Sarah. From Lakshmi Gayatri, how can I join your tour? I will be in Iceland too from Saturday. Oh, that would be great. Unfortunately, I've got just this group of students, and so we only have so much space in the van. You might see us out and about, and you're welcome to, like, if you see us out and about, you're welcome to, like, tag along and say hi and maybe listen in a little bit. But I just can't necessarily open up the floodgates to, hey, anyone that's in Iceland today, come join the tour out here. But I will be doing more trips with YouTube viewers to Iceland in coming years. I haven't got the 2025 one figured out yet in terms of when or how many people. I've got to figure out some logistics there, but stay tuned, and I appreciate your interest. Lucine Corvin, what is the chances of a dual location eruption? Smaller for sure, but not zero. So the chances of us having, two vents at the same time, we've seen it in Kilauea, but I'd say it's more the exception rather than the rule. So possible, but very low chance. Certainly at the beginning of an eruption, you might have a big fissure, and for example, with the January 14th eruption, we did have two vents. We had this vent that opened up here, and then this one that opened up closer to the houses. These were both erupting at the same time. Thankfully, this vent was pretty short-lived and only lasted maybe just a few hours or so before it kind of fizzled out and died, and so it fed a very small, limited lava flow. But there's an example of two locations, if that's the essence of your question. So could we get something like this? Absolutely. But what are the chances of having, a vent open up way over here and then something way over here? That's really, really low. But along the same fissure system or trend, it's definitely pretty possible. And then our last question here, team, Fritz46 wants to know, why do existing magma conduits close if there's enough pressure to open new ones in the same area at any moment? Wouldn't it be easier to keep the active ones open? Well, it's not so much that the conduit closes, it's just that you get lava in the conduit that's now stagnating. It's not moving anymore upwards towards the surface. It's lost the pressure and the gas buoyancy to transport it up to the surface. So that lava stagnates within the conduit, and as that lava in the conduit will cool and solidify, that essentially closes the conduit. But there's this kind of window where if the lava is still fairly molten and hot, then it's an easy pathway to move a fresh supply of magma through. If it's completely solidified and cold and brittle, it essentially acts like rock, and then you have to build up pressure and break it. And then interestingly, if it's somewhere in between where it's mostly solidified but maybe partially molten still, like maybe a 50-50 split between the two, it doesn't break easily, so it's hard to get the magma to move through by brittle failure, but it's also not liquid enough to allow the magma to pass through. And so it's almost more plugged up when it's kind of in that in the middle of that spectrum, in that kind of 50-50 zone. So it's not that the magma conduit is opening and closing. It's just a case of, and right now what we don't know is in this existing system is what is the nature and the viscosity of the magma in the conduit system. Is it still insulated well and still molten and thereby open? Or is it starting to cool and solidify and plug up? It's in contact with the wall rocks, and is it starting to, inhibit magma migration through the system? So, yeah, really good question there. You guys were on point today. There was a lot of good stuff there. Excellent. Let's see. How are we doing over here on the chat? I'll go through the chat as I always do afterwards, but anything else that's pressing from any of the viewers or from the moderators. Hopefully we had some good discussions taking place there. Anything else? So I guess in conclusion here, team, it's wait and see. It's everyone wants to know what's going to happen next because we oftentimes don't like surprises, but we just don't know. And so I think we can continue to watch the data. For me, that's very interesting to see what the data might show moving forward. What can we infer from the data in terms of giving us some indication as to what might take place moving forward. So the GPS data will be very helpful moving forward. I would pay particular attention to the earthquake data as well. This can kind of look overwhelming at times. So you can always come in here and select out some of the tiny earthquakes. At the same time, you don't want to eliminate all those small earthquakes because they are telling us something. And we'll just see what things transpire over the next couple days. I'll be sure to do, what's today, the 9th? I'll probably do an update on Monday the 13th before I leave. My flight doesn't leave till 5 o'clock, so I'll probably do an update that morning. Of course, something could happen between now and then, so I'll try to jump on and give you an update prior to that. Might even do one on Saturday as well. We'll have to see if there's new data coming in and something to discuss. I'll try to be as up to date as I can with these sorts of things. So otherwise, we'll just kind of see how this shakes out. I'm excited for my trip to Iceland, excited to meet Amanda Joe for the first time. Really looking forward to seeing some new places and putting together some new videos in North Iceland. I'm even going to do a random road cut in Iceland. I don't know where exactly. I've got a couple places on Google Earth. I'm like, that looks like a road cut. So I think we might do that as well. So those are some of the things to look forward to. I'll continue to send you more videos your way. Appreciate your support of the channel, whether it's just being a viewer here, whether it's financial support, very helpful. As always, thanks to the moderators. So Amanda Joe and Susan, thank you very much for your time today and being able to help me manage this live stream. What else? I think that's about it. I will spend time with my wife, Elaine, on Sunday. That's her day, and she gets to do whatever she wants. So, yeah, we'll make sure we do that. Yeah, please hit the like button. Make sure you subscribe to the channel. I'll circle back on some of the other things moving forward. The graphics and some of the designs for the merchandise and stuff. I got to rethink that whole thing. That is not my skill set. So we'll just kind of see how things look moving forward. But look for another update from me probably on Monday, maybe sooner. And then I will try to send you a few updates when I'm out there in Iceland, maybe even from the field. That would be kind of cool. And I am trying to get some access into the eruption area as best I can, but it'll kind of depend on what's going on and what the situation is at that time. So we will see you next time. Thanks again for joining me on this day here, and take care.